problem, um, it's a deceptive problem actually, or at least it was for me. So I made also a series of mistakes on that problem as well. Um, so on first look at the problem, it looks like a BFS problem, a typical BFS problem, just that the only difference is that instead of you picking just one point and then traversing until you reach at a target, this one you have like a number of points and you're going to make your move on all those points simultaneously, right? And so when I first saw it, I was like, maybe this is what it's supposed to be. And but that solution just didn't work, you know. And so after viewing it, I came up with another solution, which was, wait, I am not drawing. I thought that I was drawing. Give me a minute. This is 11011. Okay, so we have this grid, and it is divided into 9 parts, right? There's one, there's zero here, there's one, there's one here, there's one, there's two, there is one. The question is saying that all the numbers in this grid must sum up to 9, and every cell must have 1. So if we look at this cell, there is 2 in there, right? And so like we need to get one of the numbers to this point. And so how many steps is it going to take? So if we make the first move, sorry, here is 1, here is 1. We can probably move this 1 into this place, making here 1, and leaving 0 here. And then there is 1, there is 1, and then there is 1, there is 2, and I guess we can also move this one from this place into that section. So like we'll have 0 here, and then this place will no longer be 0, it will be 1, I guess. Then once we reach this stage, we can now then move another one here, right? And so overall, it took us 3 steps to get this one done. And so one way of viewing this problem, instead of like making these like moves, we can just view it as like we can just flip the question. We can just interpret the question differently. That okay, if we have a 0 somewhere in the cell, where is the like which is the nearest cell to the 0? Like what is the nearest cell to the 0 that has more than 1 in it, right? And so if we see the nearest cell is 1, 2, 3 steps away, so we have our answer 3, right? And so this is one way of solving it. And so like if you look at this, you think that okay, then it is just a BFS solution, right? But no. And how I got to know that was through this example. Wait, let me look at the example. Let's find this other example. During the contest, oh, because like this one, okay, fine, fair enough. Let us use the second example also. The second example, we have 1, 2, and then 3. Fair enough. There's 1, there's this, and then there is that. Let's cover this one. There's 1, 3, 0, 1, 3, and 0. I think there's a 0 here. There's a 0 here too, if I'm not mistaken. Then there's a 1, 1. Then there is a 0 here. There's a 3. Again, using our new interpretation, we can say that okay, for this one, what is the nearest number that is more than 1? It is this guy. So we can just put 1 here. So like it was 1 step away. So this is no longer 3, it's now 2. If we get to this 0, what is the nearest this one over here? It is this guy. And so we can just take, so we make 2 steps. This one is now 1 and this one is now 1 because we've used 2 of it. We get here, the nearest this one is here, so why am I getting this one? It's 3, so now this one becomes 1, this one is now 2. The nearest this one is 1 step away, so this one becomes 1, this one becomes 1. So if you look at this, you think that okay, it is just BFS, but we are just going to find the spots of all the zeros and then do it, how do you call it, simultaneously, right? Find the nearest distance. But the problem arises if, say, we have a problem like this. This was where I ran into problem during the contest. I could not think clearly about all the possible edge cases. So let me see if I still have that problem. It was something like this. Let me see. A bit of an issue with the previous drawing this thing. So yeah, okay, so this one works. So the thing is that one example that clued me in as to what the solution should be was this. If we are given this example where we have a 0 here, we have a 2 here, we have a 3 here, we have a 2 here, and we have a 0 here, and we have a 1 here, and 0, 1, 0, right? Let us go back to our previous distance that we said we pinpoint all the zeros, so these are the zeros, and then we will try to find which one is the closest, right? So here, for these two, all of these, no, for these guys, so like if we start here, this one might pick this one, right? It's like our algorithm becomes like very hard for us to control which one they're going to select first, right? Because like when we get here, we can either give the one to this guy or give the one to that guy, right? What is going to be like the determining like decision, right? So here, if we say okay, fine, we give like the one from this guy to this place, right? So the closest non-zero, this one, like the algorithm that we are using right now, once we get here, it can either choose to pick it from here or choose to pick it from here. But if we pick it from here, it is going to have a diabolical, like it is going to affect the answer that we are going to have. Let's see, if we decided to pick from the bottom instead of picking from here, then this is what we have. We will wind up with one here, one there, and 0 here, then 2 here, then 0, then 1, then 1, then 0, then 3, right? This one can also pick from here, and so this one becomes 1, this one becomes 1. So now we've made 2 decisions. Then we are now left with here. So this one will pick 1, 2. So this one is 1, 2. So we add 2 to it. So we now have 4. And this one is 1, 2, 3, 4, which will give us 8. But is 8 the best that we can do? Is 8 the best that we can do? I don't think so. I think that we can do better than 8, right? How can we do better than 8? That is, if we decide to pick from here instead of picking from here. So we first made this one 1 and made this one 1. So we've picked 1 and we decided to pick this guy from here. So we now have 1 and 1. So we now have 0 and 0 and 0 and 1 here, right? And then we now pick, this one is 2 steps and 2 steps, right? So this one now gave us, since we picked 1 1 from here, we now have 6, which is a whole lot smaller than this one, right? And so after seeing this example, I sat down and I thought about it. Then I came to the conclusion that, okay, how we pick um, like this grid is small enough for us to try every possible combination, right? And so after seeing that, okay, it is small enough for us to pick every combination, I immediately went to backtracking, because backtracking is when you try all the possible combination to see which one is the best possible option, right? So how are we going to pick the, like, how are we going to do the backtracking? So with backtracking, what we are going to do is that, okay, we said, okay, for this 0 we can either pick this one, it doesn't matter, right? So we mark this one as 1. Then we will continue. When we get to this 0, since this one is no longer 1, no, since this one is no longer 2, we are now left between these choices, right? So we can either pick this choice or this choice. It doesn't matter. Like, the aim of backtracking is that we are going to try all the possible options. So like, you see that, like, here, this one picked this one, and then this one picked this one, and then this one, I guess, picked this one, and this one, I guess, picked this one. It doesn't matter. On the next run, instead of this one, like instead of this 0 picking from here, it can either pick from this 3 or pick from this 2. So like, we are going to try every possible option. And now, instead of this 0 picking from this 2 or this 3, it can either pick from, sorry, instead of this 0 picking from this 3, it will either try picking from 2 here. So like, we are going to try every possible option, and then the one that will give us the smallest possible answer, that is what we are going to take. And so like, this solution is intuitive and easy to do if you understand backtracking. I'll make sure that I add various resources to the description so that you can read up on backtracking. And so, yeah, that is the solution. We are going to attempt to solve this problem with backtracking, where we will assign every 0 to any of these, like to any combination of these numbers. And then at the end, we will check which of the combination gave us the smallest possible answer. Well, like you might be thinking that, okay, but backtracking, if we backtrack over this one, wouldn't the time complexity be O of n to the power 4? And like, yeah, you are right. O of n to the power 4 is a really big time complexity. But remember, this array that we are dealing with is a 3 by 3 array. So we are looking at, is it 9 times 9 or so, which is just 81. So 81 is not a really big number by any stretch of the imagination. And so this one is nothing, right? So like, yeah, so like, there are around like 81 possible like combinations that we have to check, and then we'll just pick the smallest of them all. So yeah, that is the explanation. Let us jump into the code. So yeah, I made a ton of mistakes. So this was my initial distance. I was trying to use BFS, and this is the one that got accepted. So I will just explain the code to you. So here we are just going to walk through like the code in the shape of like, this is our recursive, this is our So this is our recursive, how do you say it? This is our recursive backtracking solution. I think you can do it iteratively, but doing it iteratively is a bit difficult, as you have to use a stack or something. And so, yeah. So, this is what we are doing. So, what I did was that I have now changed, how do you call it? Since there are 9 distinct, right? I have given every cell a number. So this cell is cell 0, this is cell 1, this is cell 2, this is cell 3, this is cell 4, 5, 6, 7, 8. And so if we get to cell 9, that means that we have jumped out of our grid, right? And so what we are doing here is that we are checking if every cell contains 1, because the question is saying that at the end of the distance, all the cells must contain 1. And so if all the cell contains 1, then check the count, right? Remember that we said that the count is like the count is the number of steps that it took us to achieve this one. So like if all the cells contains 1, then we are going to check the number of steps that it took for us to achieve the score, and then we are going to find like the minimum of that one. So like we initially said that we initially set our final answer to some large number, and so we are now going to check if this is the case. Then we will find like the minimum of the count and our large number. So that is it. So now let us get to the actual bones of the recursive distance. So we now start at this position. Is this position 0? No, it is not. Move on. Is this position 0? No, it is not. Move on. So like that is what is happening here. So we get here, we are going to check, and like how we are changing the 0, like this how we numbered this one as 0 is very simple, because like we have like a 3 by 3 array, right? So that means that there are 9 cells, right? And so if I have like if I want to name this one as 0, what I am just going to do is that I am going to find like this guy's cell number is I guess it is on row 0, column 0, right? And so if we multiply this one by 3 and we add this one to it, we get 0, right? And so like if we have 0 and we want to change it to the if we have 0, like if we have like the number and we want to change it back to the coordinates, so like this is if we have the coordinates and we want to change it into like into like its index, then like so like this place was 0, 0, right? So like this one is 0, 1. So like if we had like the coordinate and we wanted to change it into a number, then we will say we will multiply the r by 3 and then we'll add c to it. So like 0 by 3 is 0, plus 0 is still 0. 0 by 3 is still 0, plus 1 will give us 1. 0 by 3 plus 2 will give us 2, you see, and then it will be giving you those numbers. And like if you have the number and you want to change it into the coordinates, then what we are going to do is that we are just going to take that number that we have, we're going to divide by 3, and then the column we are just going to mod by 3, right? And so like that is what I'm doing here. And so this is the algorithm. It starts from 0 here and then it checks. So it breaks it back down into its xy coordinate, like using this formula that we just described over here. And then it will check, is this point 0? It is not. So move on. is this point 0? It is not. Move on. Then is this point 0? It is. If that is the case, like find the place which has more than 1 in it, which is this place. And so subtract 1 from it and add that 1 to this guy, right? After that, like the number of steps that we took to get here. Remember from the BFS solution, right? The number of steps that we took to get here is basically the Levenshtein distance, right? Which is like the difference between their x's and the difference between their y coordinate, right? And so we just add that one to the steps and we call the grid again. And then because we are backtracking, we undo what we did up here, and that is the solution. And so at the end, we will check if we reach the end of this grid, then we will check if everything is 1, and then we will find like the minimum between this one and that one. And then at the end, we will just return our total answer. And this is the solution to the third problem. It is a backtracking problem, and yeah, it is not as intuitive from the first look. At least it was for me. But after seeing some of the examples, I was able to figure this one out. And so let us check if this one works. It does. And yeah, it is also very efficient. And so that is the solution to the problem.